All right. Good afternoon, you guys. You got a copy of this in front of you, and here's the situation we're looking at today. We're going to suggest that maybe you're at Home Depot, you're buying some fertilizer for yourself. It's Prince George. The grass is finally exposed again from under the snow, or maybe you've been sent to buy some fertilizer. Who knows? Maybe you're selling fertilizer. Maybe you're working for a company that fertilizes lawns. But one thing you're going to see if you start kind of shopping around and looking at some products, you're going to see pretty quick they've got some numbers here. They've actually got a ratio, and it's a 3-term ratio right on the front of the bag, and every bag has these 3 numbers on it. This bag is a 2848 bag of fertilizer. It's called Pro Turf. It's $55. Scott's is a product. It's a 3003 bag. It's a Turf Builder lawn fertilizer, and it's $44. So what's the deal? Well, if you dig around, again, you're going to see different things on different products, but the key for fertilizers is that that these 3 things are happening. These numbers are NPK numbers, and if you dig around, you're going to notice that the first is a percentage of nitrogen. Nitrogen does a few things. Most importantly, what most people care about, it gives your lawn some color. It helps produce more chlorophyll, which allows plants to grow quickly. The second number is a percentage of phosphorus. We've got a different chemical in there. Phosphorus helps with root growth. So they suggest here, if you're putting in a new lawn, planting a new tree, you want some phosphorus in your fertilizer. The third number is potassium. Potassium guards against disease, drought, and cold tolerance. So in Prince George, that third number is probably a good idea. Every fertilizer, every bag you see has the 3 numbers, and that's what they do. This guy here, you'll see, has no phosphorus, right? It has nothing at the second number. So here's the 2 again. Here's what we're looking at. We've got this nitrogen, phosphorus, potassium on these 2 fertilizers. We're going to use terms, we're going to use ratios to compare them, right? Just to kind of look at the differences. And you notice I'm kind of kicking around this term word first. And the one thing you're going to see when we start looking at ratios is that if we talk about in that first thing, 28 to 4 to 8, each one of these is a term. The 28 is a term, the 4 is a term, the 8 is a term. Each number is a term. And part of their identity is their place in this ratio, right? We said earlier this is nitrogen to phosphorus to potassium. So if we rearrange, it's not the same as 4 to 28 to 8, right? These can't switch. Because in this ratio, we're taught the 28 goes with the N, the 4 goes with phosphorus, and the 8 goes with potassium. So that term is kind of both that piece and its place in the ratio. That's significant, and that's why we talk about 2- and 3-term ratios and use this new language here. Another thing you're going to see is the forms. That form on the bags isn't common. It's not really a mathematically common form to stick a hyphen in the middle here. We're not going to use that. We're not going to see a lot of that. What we are going to do is what I just did. We're going to put a colon in the middle. So we might have 6 to 7 to maybe, I don't know. Could be anything, right? 6 boys, 7 girls, whatever. We could just compare. Well, let's do some. Yeah, we'll get to some examples in a minute. But we could also, if we're talking boys to girls, 6, 2, 7. We could use a colon. We could use a fraction. We could write it out. Any of these are kind of a typical a form or ratio notation. You might see that language as well. Just something to be aware of as we start rolling here and kick around this language. Examples. Let's come back to our bags of fertilizer here just to talk about a couple quick examples. This turf was 2848. The Scott stuff was 3003. So if we were to look for a 2-term ratio, we could compare nitrogen to nitrogen. So we could do this. Nitrogen on the Pro to nitrogen on the Scotts was what? 28 to 30? Pretty similar, right? If we're making that comparison, looking at that ratio in the store, we might not think much of it. Something a little more significant, perhaps, is the phosphorus to phosphorus. So the P on the Pro to the P on the Scots was, what was it? 4-0. Right? There was no phosphorus in the Scott's fertilizer. Interesting. That was the one for root growth, right? So if we're interested in that root growth, we probably don't want to go with the Scott's product. If we're putting in a new lawn, as I said, probably don't want to go with the Scott's product. It's not really going to help us out very much there. Again, if we think about our notation or our forms, this could be written as 28/30. And we got to remember, we're talking about the nitrogen in the Pro over the nitrogen in the Scott's. Not just random numbers, it's not just 28 of anything, but it's specific things here. We could talk about this guy as 4/0, right, with the 4 being the phosphorus in the Pro, over 0 was the amount of phosphorus in the, phosphorus in the Scott's. And that's actually basically 0%. This would be 28%, 30% of the bag. So there's some 2-term ratios for you where we're just putting 2 things together. You're going to be working with those. You're going to be finding those and using those. We're going to build up to kind of the idea of proportion if we're going to start comparing one ratio to another ratio or one rate to another rate. But for now, 2-term ratios. 3-term ratios you're going to see as well. And both these bags, I picked these pictures of bags because they have 3-term ratios on them. 28/4:8 is a 3-term ratio. So that 28/4:8 is a 3-term. And notice this one we can't really write as a fraction, so this is the form, right? We use this colon form. We stick these colons in here when we're writing our 3-term ratio. Alright, just some language, just some examples for you guys today. We're going to look at 6.1, page 187, and we're going to look at 6.2 as well today. And there'll be some questions on the blog to help this sink in. Just do some practice and just try to apply this in the real world. Good luck.